Dear students, in this example, in the part 8 is given in the YDSC, that is Young's double slit experiment. Describe briefly how bright and dark fringes are obtained on the screen kept in front of a double slit. Hence, obtain the expression for the fringe width. Now, let's concentrate on the first question. And first, let's answer how bright and dark fringes are obtained. For example, we already know that if there are two slits, which are at a distance of d from each other, and we already know that the screen is at a distance capital D from the two slits. Now when the path difference, we already know in the interference of waves we can either talk about the phase difference or the path difference. So in this case, if the path difference is equals to is a multiple of n lambda, then we say it's a maxima. And if this path difference is an odd multiple of lambda by 2, or I can also write it as, for example, 2n minus 1, odd multiple of lambda by 2, or in some books we can find it as n minus half lambda is a factor of this, where n is an integer, then it will be a minima. So when two waves interfere at a maxima condition, then it will form a bright fringe, whereas for a minima case, when the path difference is equals to an odd multiple of lambda by 2, it will be a dark fringe. That is, a destructive interference will happen, and in this case that will happen. Like for example, we can have a qualitative analysis here that this point is equidistant from both the sources. So here the delta is the physical path difference that we can see will be 0, and as we keep moving higher, we'll find a place where delta will be equal to lambda, then we'll find a place where delta will be equal to 2 lambda. So here this will be our first maxima, because it's a integral multiple of n lambda. This will be the central bright fringe, and this will be the first maxima above the central bright fringe, second maxima above the central bright fringe, and similarly in between of each maxima we will find a minima also. That means we'll find a first minima at lambda by 2, then 3 lambda by 2, then 5 lambda by 2, like this. So this is how the fringe pattern will take place. So now let's obtain the expression for fringe width. That in this we'll do this again, the maxima minima concept. Now in this diagram we can see a much neater diagram in which S1 and S2 are the slits which are separated by a distance small d. And small d is considered to be very, very smaller than capital D. So we can assume that because of that instance, we can say that this angle theta is very small, and these two angles are theta that we see here. So let's first see that what is the path difference at a general point. So at a general point, what can be the path difference? So we can assume that these two lines are same. The distance is same. So path difference will be because of this component. This length is the extra distance covered by the wave from S2. So this would, using trigonometry, we can easily say that this distance is equals to d sine theta. D sine theta, and for a very small angle theta, theta should be equal to sine theta, should be equal to tan theta. Now because it is equal to tan theta, we can write theta as x upon d. So we can say that at an arbitrary x distance from the central bright fringe, the path difference is delta is equals to d sine theta or d theta, or we can also write it as dx by d. Now we can always say, if we want a maxima at the point x, at a distance of x, if we want a maxima, we can equate this path difference to n lambda. For a minima case, we can equate it to 2n minus 1 into lambda by 2, that is odd multiple of lambda by 2. So now we'll divide the screen and we'll do a qualitative analysis on both. So for maxima, we can write it for here. If you want to obtain a maxima at that point, or if you want to obtain a minima, for both the case. Now maxima, as we already know, will be a bright fringe, whereas this will be for a dark fringe. Or similarly, we can also call them on the basis of destructive and constructive. So this is constructive interference and that is destructive interference. So here we can equate delta or the path difference equal to n lambda. So we can say dx upon d will be equal to n lambda. So this will be the nth bright fringe. So we can write xn. This x would be the distance of the nth bright fringe from the central maxima. So that will be equal to n times d lambda by d. Whereas in the case of minima, we will equate this to 2n minus 1 lambda by 2. So we will say dx by d should be equal to 2n minus 1 lambda by 2. So here we will get, now this will be for the bright, nth bright, and this will be for the nth dark. So this should be equal to n minus half into lambda. And because we have equated it to d into lambda d by d, because this d will go here and this d will come down. So this will be the distance of the nth dark. Now let's define what is fringe width. So fringe width, for example, this is the central bright fringe. So basically we are going to define what is fringe width. Which is denoted by beta. It is the distance between any two consecutive maximas or any two consecutive minimas. So this, if say this is maxima 1, maxima 2. So we can say they have a fringe width of beta. So they are beta apart. So the distance of the maxima 2 from central bright fringe will be 2 beta. Similarly, it can be the consecutive difference between any two consecutive maximas or two consecutive minimas. So we will calculate the fringe width using two maximas. Let's do it using two maximas. So we will say beta should be equal to the nth bright minus x of, is for any general bright, n minus 1th bright. So between two maximas, nth maxima and n minus 1th maxima, we are finding the beta. Now we already know what xn of bright is. Xn of bright is n d lambda by d. So we go here, we write beta is equal to n lambda d by d minus of n minus 1 lambda d by d. So here this term and this will get cancelled. So we will get beta equals to d lambda by d. So this has been the derivation for finding the fringe width, which will be equal to d lambda by d. So this is the formula that we use for a fringe width, and this completes our first part. So we have successfully found out the fringe width using this basic way of finding the distance between any two consecutive maximas. So now let's see what is the second part. The second part says the ratio of intensities at minima to the maxima in the YDSE is 9:25. That means the maximum intensity that they can find and the minimum intensity that they can find are in the ratio of 9:25. 9 is for the minimum, 25 is for the maximum. So definitely this is happening because these two sources are at different intensities. Say this is I1 and say this is I2. So this is the ratio of I min by I max, that is I minimum and I maximum. So I minimum will occur at a minima and I maximum will occur at a maxima. So let's and they are asking find the ratio of the width of the two slits. So if we find the ratio of I1 is to I2, so this will also give us the ratio of the width, because we should know that the intensity of the slits is directly proportional to the slit widths. So that is why if we find I1 is to I2 should also be equal to the ratio of the width of the slits. So let's do that. So what is given in the question? In the question it is given as, this is the B part. It is given that I max by I min is 25 upon 9. Now whenever there is a constructive interference, the value of I max would be, if the intensities of the two slits is I1 and I2. So the I maximum would be under root of I1 plus under root of I2 whole square, and the I minimum would be under root of I1 minus under root of I2 the whole square. So mathematically, when we try to find out the ratio of I1 and I2 from this, so we can take the square root both the sides. We will get 5 upon 3 is equals to under root of I1 plus under root of I2 upon root I1 minus root I2. So when we take it to the other side, we'll get it as 5 root I1 minus 5 root I2 is equals to 3 root I1 plus 3 root I2. So we take all the I1s on the left hand side and I2 on the right hand side. So you will get it as 2 root of I1 is equals to 8 root of I2. So from here we get the equation as I1 upon I2 will be, root of I1 upon I2 will be equal to 4. So I1 upon I2 will be equal to 16:1. So we have found it successfully, the ratio of the two intensities, that is I1 and I2, which will also be equal to the slit widths, because I intensity is directly proportional to the width. The greater the width, the greater the intensity. So this will be the answer to our second part. So this is how we answer a question like this systematically, in which first we derive the fringe width and then calculate the width of the two slits.